Okay, hopefully we're close to being on this page. When you get here, you should be already signed into Google Docs. You can tell if you're signed into Google Docs. It'll say your name up here, up there, instead of just not signed in. Make sure you're signed into Google Docs when you do that. Once you're signed into Google Docs and you're on this page, you need to save. This is like anyone in the world can see this page. You need to save a copy of this to your account. So you click the word File. That hopefully will open the file menu. You can go down to Make a Copy. It's going to ask you for a name of that copy. Type in whatever you want for that. Hit OK. That's going to save it to your account on Google Docs. You hit OK. I hit cancel. Then, once you've done that, you're going to share it the same way you should have shared a document with me. You can share and then invite people. Type in your group member's email addresses in this box, hit OK or send, and then it's shared with your group. So if they want to look at it later, use it to study for the final or any other test in the future, they can access that on their own to use it to study. Or if someone's sick or absent, they can do that as well. It's handy. And probably Tuesday. Ryan. Maybe, but you can share it. So I know you know how to. I hear you. Okay. Hi. In this document, there are some gray boxes. Those are the boxes you type your answers into. They're not just grayed out. You type answers there. And going forward. And you also, on the right-hand side, there's some boxes that answer it also. So that's what we're doing here as we go forward. So right now, if you're, want to make sure everyone's on the same page, build this circuit right here. Please don't touch anything. No, build this circuit. Make sure that in your box there might be a big bulb and a small bulb. Use this small bulb right now. Build this circuit. You can answer these first two questions, and then momentarily we'll discuss how to measure these values. Okay, but build the first circuit, save it the first circuit in the lab tech that we did before. Answer those first two questions, and once everyone's on the same page, then we'll go forward. Okay. Please make sure also if you read the instructions, hopefully you did, we also need to share that document with me so I can see what you're doing. When you turn it in, I have a copy of it as well. So go ahead and you do this peter.comfort@lsnfi.org. Peter.comfort@lsnfi.org is fine. Or the other one. Please find a shared before. That's just something Peter involved with something else. It means nothing. We're going to go over right now.
Check this out.
Okay, folks, please pay attention to the following talking. Huh? Just click and type. Did you say a copy? If you log in, go to the file menu in Google Docs. Got the browser in Google Docs.
Let's go. That's number one.
Okay, this is called, if you listen to this, so stop whatever else you're doing, sit down and listen, unless you're getting the document stuff. Stop building right now. This is called a multimeter, because it meters multiple things. For us, it will meter voltage and current. That's all we're measuring with it. It's important that you measure those quantities the correct way, because measuring certain quantities the wrong way can be damaging to the multimeter. There are two types of multimeters in the room. Some have 4 holes, some have 3 holes. They work substantially the same way. There's a couple minor differences to them. You will note each hole is labeled. Some have a V over them, that stands for volts. Some have a MA, which is milliamps, like small currents. And some have a 10A, which stands for 10 amps or a large current. The small current ones usually only measure up to 250 milliamps. So times that we're going over that, we would obviously need to switch up to the large anchor pole, which will be the first experiment we're doing, will be large anchor poles. So the black probe always goes in the common hole. That's where the negative stuff goes. That one never moves. They're the same cable. There's no difference between cables. The one's colored black for your convenience and red for your convenience. Black never moves. Never move the black one. Okay, are we going with the black one?
No.
No, never move the black one. If you do this, ask for help, I'm going to make fun of you and then help you. Okay, black stays in the common hole. The red one we're going to move. Okay, if you're measuring volts, you put it in the hole with a V above it for volts. If you want to measure current, you put it in one of the current holes. Now, if you have the multimeter like Andy has, this one, the volt and the small currents are in the same hole. So you have to move it, not move it if you're doing that. But in the big currents, you have to move it. So that's the only difference between the two devices. Okay? Now, the first thing we're going to measure is current. It's going to be bigger than 250 milliamps, so we're going to use the hole that says 10A by it. We'll put our red probe in the 10A. And then we're going to stop for 1 second doing that. Right? Okay. So how are we going to measure current? That's a great question. So here is my circuit. What is current? Current is measuring what? Amps, which is the what of the charges? Speed of the charges. So if I have a circuit moving here, sometimes I would close my switch. Close my switch. Close my switch. The current circuit's going to move. Now, the multimeter can either have a high resistance or a low resistance. If I'm measuring current, you think I want a high resistance or a low resistance?
Low.
Low. They don't want to slow the charges down. So when we look at putting it into a very, very low resistance, which is why we have to be careful. If we hook it up wrong and send a big current through it, we can damage the device. So make sure you measure the current correctly. When we measure current, we want to break the circuit. That means literally make it so the circuit no longer works. Put a hole somewhere in the circuit. So I would do, in my picture, I would make a hole right there. Now there's a hole in my circuit. It's not running. What do you think I'll replace that hole with? The multimeter. Very good. So you would take your red and black probes, when it's set correctly, and that would replace the circuit and measure all the charge now flowing through there, and leaves again. To make that work, you take your multimeter. There's several choices here. We want for current, we're always using direct current. So we'll always use one of the DCs, direct current, as opposed to alternating current. And which one, DCZ or DCA, do you think is current? DCA, DC amps. So twist your knob, so it's a 200 M next to DC amps. Then make a hole, take off one of those twos off of your circuit. That makes a hole. Then put the red and black probes in place of that, and your light bulbs turn back on again. Make sure you're using the small bulb. On mine, I have a different thing on here, but it'd be the same idea. You put that in its place, and you're going to get a reading. That reading will be whatever that number is, will be in milliamps. That number you're going to type into the spreadsheet that you saved. And that number is going to go, depending whether you measured after or before the lamp, type the number into that box. Once you type in the box, it'll stop being gray, and you'll be able to answer that. Yeah, do that momentarily. In this box right here, folks, I need you to listen one more time. It says steps to measure current. I want you to type in this box, break the circuit, and replace with multimeter in this box. You don't forget later on how to measure this. It's very important you do that. Break the circuit, replace with multimeter. You type in also, put the red probe in the current hole and those sorts of things. So put your instructions there.